Hi everyone. I received a lot of queries yesterday after our Kahoot question 3, so I thought I will explain it one more time in more detail so that it helps to clarify your doubts. So in this question, we first declare an integer variable, okay, value 130. So as we know, integers occupy 4 bytes of memory space. So integer A is here, and 130 in decimal. In the binary representation, you can write it as 10000010, and the rest of the other bits will all be zeros all the way. So that is the data that is stored inside variable A. Okay, so since it's 4 bytes, you occupy 4 bytes of memory here. Next, we declare a character pointer. Okay, and we assign the pointer to point a character pointer to point to an integer. So as we know, a character pointer should only point to a character. Okay, it cannot point to an integer. So, but since an integer is made up of 4 characters, okay, I can choose to point to one of those characters. Okay, that means one of those bytes. When I do this assignment to say that I'm pointing to a character, I'm effectively making the pointer variable, okay, point to either the least significant byte or most significant byte, depending on the way in which data is organized in the memory. We have not actually covered this yet in the lecture. So rightfully, when we have a multi-byte data like an integer or a float, there are 2 ways in which data can be organized, either the most significant byte stored in the lower address or least significant byte stored in the lower address. So let's not go into too much detail, but for now, we just take it that the pointer is going to point to the least significant byte in my multi-byte data. So when that happens, and I try to print out, okay, the value over here, what I'm going to print out is this data here. Now, we know that the default data type is signed. So when I say character variable, for example, or integer variable, whatever, by default, everything is considered as a signed variable. Signed variable means you have positive and negative. So when I do a printout over here of this data, 10000010, I can see that the most significant bit here is a 1. So that means that this is actually a negative number. And the standard representation of positive and negative is using the 2's complement system. Now, all our computing systems by default is 2's complement. So how do I get the actual value of this negative number? I need to do the 2's complement one more time on this negative number. So I do it one more time here. So I flip the bits, then I add 1. So I get 0, carry 1, 1, 1, 1, 0. Okay, so if I key in this in my calculator, I'll get the value of 1, 2, 6, and since it's negative, I put the negative sign here. Okay, so that is the reason why when I do a printout over here, for this asterisk pointer here, I get the value of negative 126. If I were to replace the character pointer with unsigned asterisk, unsigned character. Okay, if I were to replace it with unsigned in front, then I will print out what I see over here, which is 130, right? Because the data here has not changed. Okay, it is still the same 1s and 0s. But if I say that it is a character, that means it is signed. That means half of it is positive, half of it is negative. So when the most significant bit is 1, I interpret it as a negative number. But if I say that it's unsigned, then it is all positive, correct? So I will actually print out as 130. Okay, so let me just demonstrate that to you over here. Okay, so in our C program here, as you can see, this is the same code that you saw. If I were to compile and run this, okay, what you will get is the printout as you of -126 because by default this is a signed variable. Now if I were to put in the keyword unsigned here, okay, now the same thing now is unsigned. So the data has not changed, but now I'm interpreting it as a unsigned character pointer. Now what will happen? When I compile and run, I will print out as 130, okay, which is what you see here. So you can see that the data is always the same. It is just a matter of interpretation whether I say I'm looking at it as a 4-byte integer or a 1-byte character, and whether that 1-byte character is considered to be signed or unsigned. Okay, so you can try this out for yourself, play around with the unsigned and signed and see how it interprets the data differently. Okay, thank you.